Hello everyone, I am Professor Shruti Dixit, Assistant Professor in Electronics and Communication Department, Sagar Institute of Research and Technology, Bhopal. This college is under SAGE Group. Today we are going to discuss about the input-output organizations, input devices and output devices. As we know, input devices, for example, keyboard is the input device and output devices are printer. This is the syllabus of this input output organization: peripheral devices, input output interface, then asynchronous data transfer, data transmission methods, then priority interrupt, direct memory access, input output processor, and serial communication. In today's lecture, we are going to discuss about the data transmission methods, how the communication is established between the transmitter and receiver. uh, there are basic two methods for data transmission: parallel transmission method and serial transmission method. The serial transmission method is again divided into two subtypes: synchronous data transmission and asynchronous data transmission. This is the diagram of parallel transmission. As we know, the communication is the uh, transfer of information from one point to another point. Here, two points are sender and receiver, and there is communication media in between sender and receiver. There are two types of transmission media, means channel or transmission media: wireless and wired. Here we are taking the example of wired media. This parallel transmission mode, the multiple bits are sent with each clock tick. Means in each clock pulse, the 8 bits are sent together. For sending 8 bits at a time, so we require 8 transmission lines between sender and receiver. This is the parallel transmission method. Means sending operation is very fast, but at the same time, we have to maintain, we have to take care of this 8 transmission line. So generally this parallel transmission method is used for short distance communication. It is not preferred to use this for long distance. And speed is the biggest advantage of this parallel transmission method. So I have written here advantages and disadvantages. Advantage, it is speed. um, Parallel transmission can increase the transfer speed by a factor of n over serial transmission. But the significant disadvantage of this parallel transmission method is that multiple transmission medias between transmitter and receiver, definitely the cost will be increased in comparison with a single transmission line. And this method, we can say that this method is very expensive and it is generally used for short distance transmission, because if any of one of the line will be damaged, then complete transmission will be stopped. So it is preferable for short distances. Serial transmission method, in serial transmission method, the bits of a byte are serially transmitted one after another. Shift register is used for serial transmission. First, the byte to be transmitted is first stored in a shift register. Here there is a requirement of parallel to serial converter also. These bits are shifted from most significant bit to least significant bit, bit by bit synchronization with the clock, and bits are shifted right by one position per clock cycle. Here the biggest advantage is that only one transmission line will be required for transmitter and receiver. Definitely the cost will be reduction in cost. This is the diagram for serial transmission. There is single line between sender and receiver, and bit by bit transmission is possible in case of serial transmission. But there is a requirement of parallel to serial converter at the sender side and serial to parallel converter at the receiver side. Here definitely this, if we will compare the serial and parallel transmission, here the speed will be reduced in comparison with parallel transmission. But this transmission method is preferable for long distance communication. These are the examples of serial communication devices: Morse code telegraphy, RS-232, then RS-422, RS-423, RS-485, then Ethernet, SONET, SDH, T1, and even transmission lines. Advantages: only one wire is required, ultimately reduction in cost due to less number of conducting wires. It is generally used for long distance data transfer. Transmission, the speed of the transmission is quite low. Types of serial transmission: there are two categories of serial transmission: synchronous data transfer and asynchronous data transfer. This is the asynchronous transmission method. There is one start bit and stop bit. At the starting of the data, start bit is there, and stop bit at the last of the data, and there will be gaps between the data, and start bit indicates the starting of the data, the previous bit will be data bits, and stop bit indicates the no more further transmission of the data. It is called asynchronous because timing of the signal is not an issue. The information can be sent and received as per mutual agreement of the sender and receiver. This transmission is at the byte level because transmission of bits is always synchronized. Means there will be gap in between these transmissions, data byte transmission. After the stop bit, there is a time variation between the this group of datas will be varied depending on the sender and receiver mutual agreement. Start bit in stop bit, the time delay, there can be a time delay between the communication of two bytes, and only one byte is sent at a time, and there is a gap between the bytes transmission. And transmitter and receiver may function at different clock frequency, and this the main application of this asynchronous transmission. It is generally used for asynchronous modems. These are the few advantages of this asynchronous transmission: flexible data transmission method, synchronization between transmitter and receiver is not necessary. It is possible to transmit signals from the sources having different bit rates, and data byte to be transmitted becomes available to transmission can stop. This mode of transmission is easy to implement, effective scheme, and cheaper scheme. But additional bit requirement in case of asynchronous transmission, and timing error may also take place, and slower transmission rate because there is a gap between the each byte transmission. This is the synchronous transmission method. Here the bytes are continuously transmitting from sender to receiver, and there is no gap between the bytes. As in the previous case, there is a gap between the byte transmission, but there is no gap in case of synchronous transmission, frame by frame. And the clock, the as the name indicates, synchronous transmission, the clock of the sender and receiver must be synchronized. If the clocks is not synchronized, then there will be the data will not be transmitted properly. same clock rate. Synchronous means same clock rate, and asynchronous means transmitter and receiver clocks are different rate. Synchronous transmission is carried out under the control of master clock, and where here the bits which are being transmitted are synchronized to the same reference clock. The stream of bits is combined into bigger bits, means all the bits are combined into bigger frames, and one or more bytes will be there in one frame, and each byte is transmitted without gap between the next byte. And here there is no requirement of start bit and stop bit. Instead, the bytes are transmitted as a block in a continuous stream of bits. Same clock frequency of receiver and transmitter data is sent in blocks. And now it's important to note one point here: the receiver responsibility to separate the bits which which is sent in groups by the transmitter. There is an interblock idle time which is also filled with idle characters. Main advantage is speed, much higher speed than the asynchronous transmission, and there is absence of gaps between data units, no start bit, no stop bit, and timing errors are reduced due to synchronization. Here the synchronization is very important. If the transmitter and uh, receiver is not properly synchronized, then there will be error. The accuracy of the received data is dependent entirely on the ability of the receiver to count the received bits accurately, and it's receiver's responsibility to make the groups and sorting of the data, and the frame is received by the receiver, but it's receiver's responsibility to separate out the data, and the transmitter and receiver have to operate at the same clock frequency. This is the, and this requires proper synchronization, which makes the system very complicated in comparison with the synchronous asynchronous transmission. And here are some comparison points between the serial and parallel transmission. In case of parallel transmission, the transmission of n group of bits simultaneously, here the bits are transmitted one by one. Separate lines are used for transmitting each group, but here only one transmission line in between transmitter and receiver. It is suitable for short distance communication, but it is suitable, serial transmission is suitable for long distance transmission. uh, this transmission is expensive because number of transmission lines are required, but here there is one transmission line, that's why less maintenance, less cost. But this parallel transmission is not very reliable in comparison with serial transmission, though the circuitry is very simple, parallel transmission. And here there is a complex circuitry due to the maintenance of synchronization between the transmitter and receiver. But the biggest advantage of this parallel transmission method is its speed. Here the speed is less in comparison with the parallel transmission, and this is all about the different data transmission methods of between the transmitter and receiver: parallel transmission and serial transmission. This serial transmission, it is divided into the two parts: synchronous and asynchronous. Complex circuitry in case of synchronous transmission. Thank you.